All right. The first thing we're going to start out with is the area of a trapezoid. And there is a way to derive these formulas. They do relate to triangles, but we're not going to take the time to derive them. This is one that would be a good idea if you remember the formula. Okay. The most important pieces in a trapezoid, the two sides that are parallel to each other are bases. So we're going to call one of them base 1 and the other base 2. And a consistent theme throughout all of the areas that we're doing is your height has to be perpendicular to your base. Okay, so generally the height is drawn creating a triangle. It doesn't have to be that way. As long as it's the perpendicular distance between the two bases, you can use it as a height. Okay, so that's really what we're looking for in a diagram. So two bases. The two bases are parallel. That's one thing you need to know. So you can't use the legs as bases, right? The formula is 1/2 times the height times the sum of the bases. And having derived this, I think what they've done is they've taken this space and put it down here. So you're adding those bases and they're creating times the height is a big rectangle. And they figured out with algebra that if they took the area of the rectangle that was as long as both of these bases and took half of it, they do get the same area. So now sometimes it's easy to just do half of the height and multiply the result by the sum. But if you want to do all of these divided by 2, that's an option as well. Okay. In the book, they have a drawing, which I found kind of interesting. Arkansas is apparently about the shape of a trapezoid. Not exactly. I mean, no state is exact in anything. But estimating the area of Arkansas, they found that the top border is 250 miles, the bottom is 190 miles, and from north to south is 242 miles. So you could estimate the area of Arkansas using the area of a trapezoid. Again, I want to make sure you are writing the formula down first. That's the only way you're going to get full credit for these. It does also help you start to remember what the formulas are the more you write them down. So it's plug and chug. So we have 1/2 times 242 times 250 plus 190. Okay, and it's easy right here. Half of 242 is 121, and the sum is 440. So the area is approximately 5,240 square miles. Or not 5,000, 53,000, sorry. All right, now, yes. Square miles. Base, it's a subscript. The 1 and the 2 below are just a subscript indicating that the bases are two separate lengths. They're both bases, but they don't represent the same dimension. Okay? They are different. So they're both bases, but different dimensions. All right, so when I said that your trigonometry and your special right triangles and whatnot would come back, here's where the special rights come back. Yay. Okay. So you will be using some of the special rights. Your first clue with this is that 60 degrees. Okay. As I said earlier, whenever you see 60, 30, or 45, that should at least be a consideration that you might be using special rights. Now, if I started this and I completely didn't know that I was going to have to do that, I would write down the formula and say, okay, 1/2 height, base 1 plus base 2, and I'd examine what I have, and I'd very quickly realize that I have no height, right? Because this could be a height, but I don't know what that is, okay? So right here, that piece is missing. Okay. Doesn't mean I can't complete the problem, but it means I'm going to have to draw in or figure out a height. Now over here, you know, it'd be nice to have that, but we don't. So what you're going to do is you're going to draw in that triangle. And then you're going to start labeling your ratios. So across from 60 is x radical 3. Across from 30 is x, and really we don't need the hypotenuse because that's not a height anyways, so I wouldn't worry about that. And you might still be thinking, yeah, but I don't know any of those side lengths, but actually you do, because these are parallel. This is a rectangle, so how can I find just that piece?
2.
It's 2. Why? Yeah, from here to here has to be 5, right? So that means the difference has to be 7 minus 5, or 2. And since x in the ratio is 2, what is my height? 2 radical 3. So my height is 2 radical 3. And you're going to be able to leave this in radical form. I believe that's what they want you to do. So let's go back up to our formula. We have 1/2 times the height, which is 2 radical 3, times the sum of the bases, so 5 plus 7. And this is a nice easy one because half of 2 radical 3 is just radical 3, or 1 radical 3, but we don't need the 1. So we have radical 3 times 12. Well, when you multiply a whole number and a radical, you get a whole number and a radical, but where is the whole number supposed to go? In the front, right? So this is 12 radical 3, and since these were meters, that would be square meters. All right, so I'm going to have to shorten your homework because we haven't done the rhombuses and kites. We'll have to do those Monday. Okay, tell you what, the bell's going to be ringing before I figure out which ones to eliminate. So look at all the problems, but if it involves a rhombus and kite, save those. Okay? Don't do the rhombus and the kite ones. Put it in here. Have a good weekend.
Oh, it's the weekend.
It is.